Just like any video, pause it if it's going too fast, or rewind it if you need to. So a valence electron, or electrons, depends. Now it's talking about the electrons in the outermost shell of an atom. So see if you can tell how many valence electrons this atom has. Pause it if you want to try before I tell you. Now you should have said 1. Why 1? You're like, aren't those little blue circles all electrons? Yes, they are. But the valence electrons just refers to the ones in the outermost shell. So all these in here, these don't really count. Why does this matter that it has outermost electrons? Well, when something has the outermost electrons, it'll tell you if the atom is very likely to bond with other atoms, or if it does not like to bond or connect with other atoms. This atom, because it only has 1 electron, it's very reactive. It always wants to bond with other atoms to share electrons, or it wants to give away its electron. Let's look at this picture. So in this picture, this atom had 3 electrons. Remember, 2 fit in the first shell. So that shell is full. So then it has another shell. But in the second shell, if you recall, 8 electrons fit. But it only has 1. So it always wants to give it away to another atom because it's become more stable, less likely to fall apart. So it's giving away that electron to this atom that needed 1. So knowing about valence electrons is important when you're talking about which atoms are more likely to bond. Go ahead and draw the picture over here and label that 1 electron as the valence electron. The original sentence you can write is an atom with only 1 electron in the second shell has only 1 valence electron. So if you had an atom with only 1 electron in the second shell, it would be valence. Because remember, the first shell can fit 2, the second shell can fit 8, so if it only has 1, it's definitely missing electrons. Next one is an ionic bond. An ionic bond is when an atom is given away, creating a bond. So in the picture, when you saw this picture before, this electron is being given away to this one because it's unstable. It wants to give away that 1 electron and then making the other one more stable. And they actually kind of one of them becomes positively charged, and sometimes one atom becomes negatively charged because their electrical differences are thrown off because of the giving away of the electrons or the adding of electrons. That's an ionic bond. Just remember that an ionic bond, an electron is given away. Now, as best as you can, go ahead and draw the picture that is on the left-hand side for number 2, and also create an original sentence. And remember to rewind the video if it's going too fast. I also added to the picture NaCl, which is salt, is an example of an ionic bond. Now, number 3 is the last one, covalent bond. Before we move on to number 3, I just realized that number 2 said when an atom was giving away. I forgot to write down giving away an electron, so please add that to your notes. Not just an atom's not giving away itself, is giving away an electron. So covalent bond, the last one. Covalent bonds are when atoms are sharing electrons. Water, or H2O, is an example of a covalent bond. So in this picture, if you notice, there's hydrogen, only has 1 valence electron, another valence electron. It's actually missing 1 more because the first shell can fit up to 2. So it's like a magnet is looking for more electrons to steal or to borrow. So when it finds oxygen, which is right here, it actually bonds with it and it shares those 2 electrons. Hydrogen's happy because it has 2 electrons in its shell. Oxygen's happy because it had 6 electrons and it needed 2 more. So now it's really strongly bonded. When those electrons are being shared, that's called a covalent bond. Okay, go ahead and draw the picture on the left, and then don't forget to make your original sentence. And remember, water is an example of a covalent bond. So there's the picture. Go ahead and draw it. And of course, try to label as much as you can, and then move on to the next step. Have a good day.